Thank you, for the introduction. Good evening, everyone. I'm honored to give this lecture here. I'm Yu Cheng Song, a graduated student from computer engineering in our FIU. Today, the topic of my presentation is unearthing interjob dependencies for better clustering scheduling. Uh, I will introduce our topic from basic interjob dependencies background knowledge to the process of establishing a wing dependency profiler model to the actual meaning of this model and show everyone the charm of data clustering scheduling. Big data refers to a collection of data that cannot be captured, managed, and processed with conventional software tools within a certain time frame. It is a massive amount of data that requires a new processing model to have stronger decision-making power, instant discovery. The author of this paper we will introduce today is based on the research of scheduling problems in the direction of big data development, as I in my review. Let me introduce the first background. Uh, the data lake. The data lake is a centralized repository that allows us to store all structured and unstructured data at any scale. We can store the data whatever it is and run different types of analysis. The data lake is like a big puddle, which is an architecture that centrally store all kinds of data. Although there is a structure of storing this data, it's not easy to use these so many kinds of and big data. So every big companies has its own method of using big data. Among them, Cosmos is a Microsoft's most advanced technology for storing and analyzing big data sets. Cosmos Cosmos storage, Cosmos operating environment, and scope. Cosmos Storage is a distributed file storage system that mainly stores large files. And the Microsoft Cosmos architecture is divided into three layers: input layer, user layer, and storage layer. In the input layer, the scope code is submitted to the scope compiler. At the user level, computer tasks are handed over to each process node for calculation. And at the storage layer, a lot of data is copied and compared to data nodes. The data is merged to generate the unstructured data stream, and the Cosmos storage management process various data. These are the pictures of the UI of Microsoft Azure Cosmos, the UI picture. And then we uh, in this article, we call every piece of data that needs to be processed a job because every users use them to for any purpose. Due to the characteristic of big data, the dependencies between different jobs are often identified by the system. There are three methods in the system. The first one is to discover the data through the process data catalog, and the second one is to inherit it through previous active scripts, and the third type is logically related uh, inter-work flow jobs. So in the interjob dependency, the three most important characteristics are recurring, ad hoc, and hard. However, as shown in the picture on the screen, most users know little about the upstream jobs that generated their input data sets, and little about the downstream jobs that rely on the data generated by their jobs. So the author of this article has obtained 6 important data phenomena under the long-term observation of the big data of Cosmos cluster. Uh, Data phenomena under the first observation is recurring job and dependencies. The second one is priority misconfiguration. And on combination jobs, cross-organization jobs and dependencies, highly interconnected, and any jobs can load shift in time. These six problems has affected the performance of many jobs in this customer situation. So therefore, it becomes very important to propose a new profile to predict the interjob dependency. Uh, then the second part, we will introduce the related system and data source upon the which Wing dependent. And I will provide an overview of the Wing's architecture shown in this picture. Uh, Wing rely on the following data source. This is used um, in the system of the author. Uh, from uh, from from the data source, we can derive the job dependencies and instance thereof. The first one is job repo. In the on the line of the read, the job repo. It preserves the job telemetry, and for the submitted jobs, the Wing pipeline use the job repo to derive recurring jobs and their historic statistics. And the second one is a Provo repo. It tracks data provenance across Microsoft to support and compliance application. The prof repo is used by Wing to uncover historic interjob dependencies, and from there, infer recurring dependencies between recurring jobs, analysis pipe, and the Wing's data analysis pipe primarily computes of a workflow of interdependent scope jobs. Uh, those data analysis pipeline is managed by a workflow manager, and which is using in the customers, uh, and read data from the job repo, and the probe repo writes the output, which will be consumed by the Wing store. So this is the overview of the architecture and how to complete the prediction of interjob dependency. Uh, when interact when interacting with a single hop type of the data source, the left part. Oh, sorry, the left part. Uh, So when interacting with a single hop type of data source, the author abstract idealization cycle job model using the specific threshold and the median time of the job to predict whether and when the next cycle job will come. The historical provenance data is obtained by using the log of Provo repo model to make predictions in the single hop analysis. And in the multi-hop data source, when the data source are interacting, they also put forward the value concept of the work. He gives our concept of what the value of the work. So, what's the value of the work? Every user will expect more and more data to be efficiently transmitted and analytic. So therefore, the number of downloads and the target file is selected as the most important value, and the time windows is set to consider the interjob will use local view according to size the consider of the interjob and according to the dependency of the upstream and downstream jobs within a certain period of time. So therefore, on the basis of this dependency, the author proposed 5 simulation functions that regard interjob as a directed graph and for weight calculation. we use a single hop dependency as an input, uh, then use the aggregation function, pass operation and edge operation, then use the downstream operation. So they got a multi hop dependency function. And the last one, the author used the scheduling strategy. If the job is recurring, WinAct computed the job gravity value efficiency by dividing the job's median historical value. And the scheduling assigns the job's priority. If the job is ad hoc or hard or anything else, he will choose the most easy one to as the first to most easy one to choose to solve the problem. And WinX extensions the uh, jobs aggregated value efficiency based on the previous jobs and the same user has submitted. So this new system assigns the value efficiency rather than the value as the job priorities to optimize the high value throughput. Uh, so we can see uh, they use this model with yarn stock scheduling to compare with the result of three work experiments. The experimental results show that evaluations with real job trees show that uh, more value in terms of successful user downloads can be attained by using WinGuard priority assignment over those provided by user. Through such a logical process of solution, the results obtained by the author have three important as described a novel system for extracting historical interjob dependencies from province data at scalar and predicting the impact of a newly submitted job on future jobs and the user. Using such predictions can also allow a modern scheduler with minimal changes to better solve the overall workload by prioritizing the highest impact jobs. And the third one is a hidden interjob dependency in a large-scale data analytic cluster is a very promising field. So it shows that the data clustering scheduling has so many jobs and so many chances to we can explore the charm of this period. So this is my presentation. Um, thank you. So do we have any